start recording and let's go, guys. I'm here for save your day again. In this video, I will solve this problem, intersection of two linked lists. The question is a pretty simple question. In this question, you will receive two linked lists, two head of linked lists, like this. Get this linked list to get here and put the page. Okay, we'll receive two linked lists like this, and you must find the node, the common node between these two linked lists. You receive head of each, and you must find this node here. Okay, how to solve the problem? The first way, the simple way, not the best complexity, is using hash map. For example, get one of these linked lists and put all nodes in a hash. For example, iterate the first one, put all nodes in the hash. A1, A2, C1, C2, C3, and so. After that, iterate the second, checking if each node is in the hash map. Check if B1, check if B2, check if B3, check if C1, and find it. This node is in the hash, then return it. If we check, this solution is here. Start one empty hash map on that set. Put all nodes in the hash and iterate the second one, checking if the node is in the hash. If it's true, return. If you iterate the second and not find, return the none. This approach is not the best one because in the nodes, the question requires you one algorithm with O(n) time complexity and O(1) in the memory. And use the hash map, you need n in the memory because you need to store our first list. Okay, but how can improve the complexity of the memory? Okay, let's check in the paint. Z, 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 Y, and so let's go. If you notice, we need to find, you need to compare the vertices of index with index are equal, starting from the final of the nodes. For example, if you enumerate 0, 1, 2, 3, 4, 3, 4, to solve the problem, it's very simple. Is you need to compare these two vertices, of that have the same index from the final, from the end, like this. The first one that is equal in the first list and the second is my answer. For example, in this example, we will compare 4 and 4, and these two are different. If you compare the second, 3 and 3 is different, and you compare the 31, C1 and C1 is equal, then my answer is C1. But how can code this approach? The linked list is not a double linked list. Then you cannot move back from the final from the final. Okay, and then you need to calc first the length of each list. For example, in the first is length equal to 5, in the second is length equal to 6, and iterate this nodes. The first, after calculate the length, is setting in the same position of each list. In this case, the first equal position as possible is the first of the first list and the second of the second list. We can code this only iterate the greater linked list until we equals the size. For example, in this case, we start in the first with size equal to 5 and start the second with size equal to 6, and one step decrease the size to 5 and put in the second. When the size is equal, we can iterate these two lists at the same time. The first one that is equal, you can return and finish the code. Let's check here. The second solution is pretty simple. First, you need to calc the length. Second, while you have one list with size greater than another, move to the next position and decrease the size. When you have these two lists with the same size, compare. If is first equal, return. If not, move these two lists at the same time from the end. This pretty simple solution. 2 is not too complexity, not too complex, and the solution have this two requires RAM in N, and memory is 1 because you don't need extra memory, only these two variables, only these counters. Then, using this approach, we solve the problem, and so it's all. If you notice some English errors, please comment below because I am English learning. If you like this video, please give me a thumbs up, and see you next time, guys. Peace. Bye bye.